In this video, we're going to introduce another important concept in bottom-up parsing, the notion of a handle. To review, bottom-up parsing uses two kinds of actions. We have shift moves, which just read one token of input and move the vertical bar one to the right, and reduce moves, which replace the right-hand side of a production immediately to the left of the vertical bar by a production left-hand side. So in this case, the production must have been A goes to XY. And also reviewing what we did in the last video, the left string can be implemented by a stack where the top of the stack is marked by the vertical bar. So shift pushes a terminal onto the stack and reduce pops 0 or more symbols off the stack, and that's going to be the right-hand side of some production. And then it's going to push one non-terminal onto the stack, which is the left-hand side of that same production. And the key question in bottom-up parsing, and one that we haven't addressed at all yet, is how do we decide when to shift and when to reduce? So let's take a look at this example grammar, and let's think about a step of a parse where we've shifted one token onto the stack. We have int on the stack, and then we have times int plus int still to go that we haven't seen yet. Now at this point, we could decide to reduce by t goes to int, because we have the production t goes to int right here. And so we could then get into this potential state, or this particular state, where we have t on the stack and then the rest of the input that looks like that. But you can see that this would be a mistake. There is no production in the grammar that begins t times. There's no production up here that looks like t times. And therefore, if we were to make this move, we would get stuck. We could continue to do reductions, to rummage around in the string, but we would never be able to get back to the start symbol because there is no way to deal with a substring that has t times something in it. So what that shows us is that we don't always want to reduce just because we have the right-hand side of a production on top of the stack. To repeat that, even if there's the right-hand side of some production sitting right there on top of the stack, it might be a mistake to do a reduction. We might want to wait and do our reduction someplace else. And the idea about how we decide is that we only want to reduce if the result can still be reduced to the start symbol. So let's take a look at a rightmost derivation. So beginning with the start symbol, we get to some state after some number of steps. Remember, that means just an arbitrary number of steps. We get to some state. X is the rightmost non-terminal, and then the next step is to replace X by the right-hand side of some production. And remember, again, with bottom-up parsing, the parser is actually going in this direction. Okay, so this is the reduction direction. And we talk about the derivation direction, the production direction, because that's the easiest way to talk about what strings are derived. We want to begin with the start symbol, but the parser is actually going against the flow of these arrows. Anyway, if this is a rightmost derivation, then we say that alpha beta is a handle of alpha beta omega. And that just means that yes, it would be okay in this situation to reduce beta to x, that we could replace beta by x because it's not a mistake. We can still, by some sequence of moves, get back to the start symbol, by doing more reductions. So handles formalize the intuition about where it is okay to do a reduction. A handle is just a reduction that also allows further reductions back to the start symbol. And we clearly only want to do reductions at handles. If we do a reduction at a place that is not a handle, even though it looks like it's the right-hand side, or may actually be the right-hand side of some production, that doesn't mean that it's actually a handle, and we might, if we reduce there, we may get stuck. So all we said so far is what a handle is. We've defined a handle. We haven't said anything about how to find the handles. And actually, how we find the handles is going to consume much of the rest of our discussion of parsing. At this point, we know enough to state the second important fact about bottom-up parsing. So in shift-reduce parsing, handles appear only at the top of the stack, never inside. And in fact, this is what justifies using a stack, because that string to the left of our focus point, we know that all the action will take place immediately to the left of the focus point. We won't have to dive down into the string to look at its innards, and therefore a stack will be sufficient. So here's an informal proof that handles only appear at the top of the stack, and this is by induction on the number of reduce moves. So this is true initially because the stack is empty, and so we don't. So the only possible reduction is at the top of the stack if there's an epsilon move to make. And immediately after we reduce, the rightmost non-terminal is going to be on top of the stack. So immediately after we perform a reduction, we have our stack, and then we have a non-terminal, and then our vertical bar, and this is the rightmost non-terminal. And since this is a rightmost derivation, that means that the next handle has to be somewhere to the right. The next handle has to include something that, possibly it includes some of this stuff, but it's either right here at the current focus point or it's to the right, because we can't be doing any reductions to the left of the rightmost non-terminal. And so it's going to require a sequence of shift moves to reach the next handle. So once we have this non-terminal on top of the stack, it is by definition the rightmost non-terminal, and so the next handle has to be somewhere to the right of that. Therefore, in shift-reduce parsing, handles always appear at the top of the stack. Handles are never to the left of the rightmost non-terminal, and this is why shift and reduce moves are sufficient. The shift move only moves the vertical bar right because we never need to move it left. And bottom-up parsing algorithms are based on recognizing handles. So as we saw in the example at the beginning of this video, just because you have a right-hand side on top of the stack, that doesn't mean that it's a handle. And so we need to be smarter about where we perform our reductions.